Hi everyone. So I'm back. We are now on 6.6 applications of rational equations. So as you can see, we are beginning with a review of um, simple operations involving rational expressions, beginning with this one. So let's get started. Um, okay, hold on. Okay, here. 2 over v minus 5 over 4v equals 3. So I think it makes sense to get rid of the denominator, which is what I usually do, and I intend to do that by multiplying everything by 4v. All right, by multiplying everything by 4v, so when I multiply this by 2 over v, the v cancels out. However, I still have a 4 that would be multiplied by the 2. Okay, so this is multiplied to this, I will have 8v over v, or just an 8. Okay, there you go. And you have to do the distributive property. That would be 4v times negative 5 over 4v. The 4v cancels out, leaving me with just minus 5 is equal to 12v. Okay, now what happens? 3 is equal to 12v, or v is equal to dividing both sides by 12. V is equal to 1/4. All right. Whenever possible, see if you can actually plug it in so that you will be able to check your work. So let's just quickly do that. So 2 over v to check. 2 over v equals, what's that? 5 minus 4v, or no, minus 5 over 4v equals 3. All right, so plugging it in, 2, 2 over 1/4 minus 5 over 1/4, all right, which is multiplied by 4 right here. Let's see. Okay, is that going to give us a 3? So now take a look. This one, 2 divided by 1/4. All right, you will flip over that. The 1/4 makes it a 4, multiplied by the 2 gives you an 8. Or another way to look at it is $2 divided into 25 cents, you have 8. While for this one, as you subtract, this cancels out, so that gives you just a 5. And are those two the same? And obviously 3 is equal to 3, and it checks out. Okay, so for this one, I leave you with this to do, and I will be moving on to the first checker understanding. So this is a distance problem, and I have highlighted here something that you should remember. Speed, time, and distance are connected such that speed times time is equal to distance. Okay. In physics, you probably have used this, and I think the way physics teachers, including Mr. Billerin and Mr. Su, would do it is they have a triangle like this, and then it's like this, and then B is up here. Speed times time is equal to distance, or something along those lines. All right, that's what they have. Okay, so anyway, it's already here, so I don't need to do that anymore. Again, just remember speed times time is equal to distance. Now, a few things for you to remember. So let's take a look at the question. A boat travels at an average speed of 15 kilometers per hour in still water. What does it mean? Well, when you're on the ocean, or when you're in a river, there's the speed of the current, right? So the speed of the current will affect the speed by which your boat would be traveling. What this first sentence is saying is that suppose there is no current, all right? Just again, just for the sake of discussion, so let's say you are in still water, the average speed of this boat is 15 kilometers. Now the same boat travels 12 kilometers downstream, all right? Downstream means that it is going with the current, all right? So the boat is traveling 12 kilometers downstream and it is going with the current. Okay, so it's being pushed by the current. And it takes the same amount of time for it to be able to travel 8 kilometers upstream. Okay, this time upstream means it is going against the current. So if you are going to think about what this is saying, so the boat is able to travel 12 kilometers with the current for a certain amount of time. And it would be the same amount of time that would take to travel 8 kilometers upstream against the current. Now you might be wondering, how come they have the same amount of time, but it the boat is able to travel a longer distance, 12 kilometers downstream, while it is only able to cover 8 kilometers upstream? Well, reason being that as it goes downstream, it is going with the current. So the idea is the speed of the boat is being pushed by the current, or the boat is being pushed by the current. So the speed of the boat is increased by the current. So if it is going upstream, so the boat would be sort of pushed back by the current. So even though it is moving at 15 kilometers in still water, if the speed of the current is just saying like 5, for example, so upstream it will be 15 minus 5. All right. So let's take a look at how this is solved. So what is the average speed of the current? That is what we are looking for. Since that is what we're looking for, that is your unknown. Therefore, that would be your x. Okay. Now, I would suggest that this is the kind of table that you create. This is a table that you will see in most books. It is very, very helpful to create a table like this whenever you are working on problems such as those that involve speed, time, and distance, or work, which is going to be checker understanding number 2. So let's just finish this. So what is the speed of the boat as it is going upstream? Well, in still water, if it is moving at 15 kilometers, but then upstream, it is going against the current. Therefore, if the current has a speed of x and the boat is going against the current, so that means the boat, which initially has a speed of 15, is actually now traveling at 15 minus x. All right, that is the speed of the boat. Why is it 15 minus x? Because the speed of the boat in still water is 15. However, it is going against the current, and the speed of the current is x. Therefore, the actual speed of the boat as it is moving upstream is reduced. It is now 15 minus x. Now downstream, what is the speed of the boat? Well, it is going with the current, so the speed of the boat is 15, and it is increased by the speed of the current. So now the speed of the boat is actually 15 plus x. That is how you do it in math. Okay, so what would be the time? Well, we don't know. Or is there a way to figure it out? Well, there's no time here, as you can see. So let's go to the distance for now. And there's a reason why I want to go to the distance for now, because you will be able to eventually realize that, oh, that's the reason why we have to have the distance and the speed, which would allow us to get the time. So anyway, the distance is given. This 8 kilometers is given here. Upstream, it says it's able to travel 8 kilometers. The distance downstream, this 12, is given by this, all right? So those are the things that we know so far. If we are going to figure out what the time is as it is moving upstream, all right, remember that speed times time is equal to the distance. Therefore, this times this is equal to this, right? Now, if this is what we are looking for, therefore, it would be distance divided by the speed, right? If the time is what you're looking for, the distance would be, the time would be equal to the distance divided by the speed, or 8 over 15 minus x is the time it takes to be able to cover the distance of 8 kilometers upstream. What about downstream? Well, same thing. To figure out what time it takes or how much time it takes to do that, it will be 12 divided by 15 plus x. So that is what we have so far in the table. And how do we make the connection? This is where usually kids would be stuck until they realize that, oh, isn't it that what this is saying is that the boat travels 12 kilometers downstream in the same time as it travels 8 kilometers upstream? What does that mean? Therefore, this amount of time that it took to go upstream is the same amount of time that it took to go downstream. Therefore, there is your equation. 8 over 15 minus x is equal to 12 over 15 plus x. Okay? Some of you would say cross multiplication. All right, fine. Okay, I'll be okay with that. Uh, not to say that it is wrong. That's okay. All right. So this one would be what? That would be 8 times 15. That's 120 plus 8x. Okay. Equals, let's multiply going this way, this time. 15 times 12 is 180 minus 12x. We have to gather everything on one side, or all of the variables on one side, all of the numbers on the other side. So I think I'm going to move this over to the left side to make it positive. And this move to the left side would make it plus 12, makes this 20x. This moves to the right side, makes it minus 120, and this is now a 60. And dividing both sides by 20, the answer is x is equal to 3. All right? What does that x represent? Oops. Okay, sorry. Oops. Something happened. This one. Okay, sorry. Okay. So, again, okay. I will have to redo this. So 20x is equal to 60. And as I was saying, dividing both sides by 20, x is equal to 3. What is that 3? Well, what is our x? Let's go back to our definition. The x is the average speed of the current. Therefore, the answer is x equals 3, or the average speed of the current is 3 kilometers per hour. And there you have it, folks, for the Get Started and Check Your Understanding number 1. Thanks for watching. Bye now.